In the last section, we talked about multiplying polynomials, and so we had, you know, monomial times a monomial, and a binomial times a binomial, and polynomial times a polynomial, things like that. Now we're going to be dividing polynomials. Now they can write it a couple ways. They can either have a polynomial, you know, like x squared plus 2x plus 1 divided by another polynomial, x plus 2, something like that. Or they can write it, you know, x plus 2 plus 2x plus 1 over x plus 2. But both of those would be division problems. In a division problem, this is called the dividend, and this is called the divisor. Well, that's not how you spell divisor. Up here, this is the dividend, and this is the divisor. So when we go to work with these, it's important to know which one you're dividing into which. Okay, so in this little part, we have monomials that we're dividing. So in example 1 here, we have this, negative 72 a to the 7th b cubed, over or divided by 8 a to the 12th b to the 4th. And then I would use the rules of exponents or canceling, you know, to do this problem. So I know 8 goes into 72 9 times. It's going to be, my answer is going to be negative. And then I have more a's in the denominator. So that's going to give me an a to the 5th in the denominator. And I have more b's in the denominator also. So I'm going to have 1b in the denominator. I would do it kind of like that, just with a canceling thing. And so my answer is going to be negative 9 over a to the 5th b. And that would be done. Okay? So it's just one term in the numerator. The term has 3 different bases, but it's all multiplication in the numerator. And same thing in the denominator. Okay, so here's another example. Well, it's kind of small. I'm going to write it a little bigger. And I just take each piece, you know, one at a time. So what goes into 28 and 49? It's 7. So I'll color coordinate it. 7 goes into 28 4 times. 7 goes into 49 7 times. Okay, now I'm going to do the x's. Those 5 are going to cancel with 5 of those. That gives me x to the 4th. It's important you put where it is in the denominator. Now, if you're thinking, well, I don't like doing it that way. I would rather use the subtraction rule. That's fine. So you could say x to the 5 minus 9, but that's x to the negative 4. And then you're going to have to make it 1 over x to the 4th at some point because you're going to want positive exponents in your final answer. Okay. And then what about the y's? Well, 12 of those are going to cancel with 12 of those, and that's going to give me a y squared up in the numerator. So what's my final answer going to be? It's positive. I have a 4 in the numerator and a y squared in the numerator. In the denominator, I have a 7 and an x to the 4th. And that would be done.